Welcome back from our MR headquarter in Regensburg to our MSENSE digital event. Our next session is the first FAQ session for today. Tobias Gruber and Jürgen Schübel will now answer all of these questions. So please, Jürgen and Tobias, come on in. So I just have the first question up for you now. How can you save cost through function integration?
Should I answer this question? Yeah.
Yes,
It's
please.
obviously, I think this question is concerning an intelligent transformer and intelligent transformer device. So in terms of ethos, for example, I'm standing right in front of one. Maybe I can open this cubicle so you can see a little bit what I am talking about. So the question is very good, I think, because you can see this whole cubicle is performing various tasks on the transformer. So the voltage regulation, the temperature monitoring, the bushing monitoring, the tap changer monitoring, and the DGA monitoring. So all the different sensors and devices are wired to this single central interface. And what you can hopefully see is that it's not a very tall and big cubicle. This is because of function integration. So for example, for the thermal measurements and the thermal calculations, you need the load of the transformer. And you also need the load of the transformer for the voltage regulator. So you just need to measure the load once. And you also need just one CPU for all the different apps and all the different applications on the transformer. So that's why it's sufficient to have the input-output modules, to have a CPU, and wire all the sensors that you need for the application to one single interface. And so it's a lot easier in terms of how to connect it, but also you can save a lot of costs in terms of the wiring of the different sensors, but also in terms of the hardware that you need to install inside the cubicle. So I hope this answers the question. If you have a further question or additional question regarding function integration, please ask your question in the live chat, and my colleagues can help you to clarify further questions about this topic.
Thank you very much, Tobias. The next question up. Does a DGA system replace the installation of a maintenance-free breather?
The installation of a DGA system does not replace the installation of a breather. The function of a breather is to get rid of the moisture from the outside into the transformer, into the oil of the transformer. That's more or less, it's an active part. It's a demoisturing system. The DGA is an analysis system. Yeah? You get information about the concentration of the gases and the concentration of the water content in the oil. The breather, it holds back the moisture from the outside, from the environment. And the breather assures more or less that your insulating material stays quite dry. The DGA systems analyze these parameters in the insulating oil.
Thank you very much, Jürgen. The next question up right now. Is your intelligent system open to integrate different kind of sensors?
I would answer this question, yeah?
Yeah.
Okay. Yeah, so this system, of course, this was one of the major tasks for us in the development to make it open for every system that is, or sensor, kind of sensor that is out there. Of course, there are many, many sensors of many, many vendors in the world. And so we had to think about implementing independent open interfaces like 4 to 20 milliamps, 0 to 10 volts, digital inputs, outputs, but also the connection of sensor bus systems to our intelligent system, to ETOS. And it's possible to, if these sensors also have a standardized way how to communicate, and it is described in the operating system, it is possible to integrate it into ETOS. We have pre-installed the more typical sensors, like a temperature sensor, oil level indication, and all these kinds of sensors already. So it's then once it's all wired, you just map the functions to the signals. And in terms of the MR sensors to MSENSE, it's pre-configured. What does that mean? So it means that when you, for example, have a DGA sensor or an M-trap or a bushing monitor or a temperature monitor, it's pre-installed, pre-configured in ETOS, and it's basically just connecting the Modbus system to ETOS. And then, so it's basically like plug and play. You choose the right sensor from the right address, and everything, the mapping and the limit values and everything is performed by ETOS already. So it's much easier to integrate MSENSE into ETOS. But of course, it's possible to integrate all different kinds of sensors from different vendors, from third-party vendors, and also existing sensors that are already existing on the transformer to ETOS.
Thank you very much, Tobias. The next question. How could I compare different sensor values, for example, DGA, with the temperature or the loading of the transformer?
I think it's also a question for you, huh, Tobias?
Yeah, as in ETOS, we include all the different data sources from various sensors, from the actors also into one single interface, one intelligent interface. You can correlate the DGA values also with the temperature or loading curve and see is there a correlance between the values, or is maybe the DGA values, are they exceeding a certain either absolute limit value or also rate of change value. Also comparing it to the temperature, comparing it to the load, because I have also asked the expert, the DGA. So in my understanding, the DGA also correlates with these two values, with the loading, with the temperature.
Yeah, it does. Yeah.
Mm. So an expert can have a look at the values and can have a look on ETOS. Is it in a normal, in a typical way how the values look like? And if not, you can take further steps of investigation.
Great, thank you, Tobias. Another question from our customers. Does your system, I assume they're referring to the ETOS system, does your system require a permanent connection to the cloud?
That is a very good question, and the absolute answer is absolutely not. So what we want our customers to do is to be the owner of their data. So we don't have any access to the data, the transformer manufacturer doesn't have any access to the data, and no one else does have access to this data. So it's upon the customer, the utility, to choose how to connect Ethos to their system. So it can be to the SCADA system, for example. So the standard way to connect intelligent control devices in the grid to a central system might be the SCADA system, or to an enterprise asset management system. So this could also be a way, and there you could use different ways to communicate, to get the data from Ethos to this system. So it could be in terms of the SCADA system, for example, 61850, 104, Modbus or DMP3. And in terms of getting it to other systems, you might also think about using MQTT, which is basically a cloud technology, but you can use it also in your private network. So you could use the technology on the one hand, the cloud technology, and use the benefits of these technologies, but to have it in a private network and not over the internet. If you want to communicate over the internet, we also offer this solution. So it's possible to have MQTT, also encrypted, but it's upon your decision and your rules how to connect Ethos to other systems. So Ethos offers the possibility, but it's not necessary, and it's also not recommended to do it unprotected, in an unprotected way. Because as I was talking about the topic cybersecurity, you really need to take this into account.
Thank you very much. So to quickly sum up, we offer all the options to the customer, but it's their free will to choose if they want to connect it to a cloud system or not. So
exactly.
Yes.
Yeah. So Ethos offers several kinds of interfaces. But if you use this interface or not, you can choose it how you would like it.
Great. The next question. What is your recommendation in terms of DGA systems to use 3 gases, 5 gases, or 9 gases?
Yeah, that just in a short sentence, it depends upon what you want to do, what you want to achieve with these results. So it depends what is your maintenance and your operation philosophy. Do you have very critical equipment? So it depends on the criticality of your equipment you want to monitor. So with the DGA 3 system or the DGA 2 system, you have a quite simple, robust system for early warnings and for get the first information that something is happening. You can't do deep analysis with this system, no diagnosis. So you get the information, something is happening in your transformer, for example. Then you can decide, take in an oil sample, send it to your oil laboratory, and do all these analysis that that laboratory can provide you with, and can get into a deep root cause analysis. That is one way to go. When you use the DGA 5, for example, you can do a bit more of a diagnosis. You can decide between thermal electrical faults directly with the results from this system. And with the DGA 9 system, you can do the full DGA interpretation according to the standards, the IEC and the IEEE standards, according to the Duval's triangle, according to the different gas ratios these standards provide. So the question that there's no right or wrong to say you have to use this system. It depends. What do you want? What fits in your complete philosophy of operation and maintenance?
Thank you very much, Jürgen. The next question. What do you consider an intelligent transformer?
What do I consider an intelligent transformer? So I had a presentation about this, and it will be also again at 3 p.m. European time where I have a definition of what I or we as MR define and how to define an intelligent transformer. So basically, maybe very short, because I already answered this question in the presentation, is to have a single central interface on the transformer where all the different data sources, so from the actors, from the on-load tap changer, from the cooling control, from the conventional sensors like temperature sensor or oil level indication, but also from the intelligent sensors like we show you this week from MSENSE, so from DGA, from bushing monitoring, from OLTC monitoring, from temperature monitoring. So getting all this information, data sources into one single interface, doing some calculation there, doing some recommendations and event generation, and also communicating all these information, all this data to subordinate levels. And one major important step is also having access to control the transformer. This really opens up a lot of possibilities to make transformer intelligent.
Thank you, Tobias. The next question, very interesting for you. Is the measurement of nitrogen necessary in the gas matrix of an online DGA system?
So just doing DGA analysis and the according interpretation to these results, the nitrogen measurement isn't necessary for that. You measure the nitrogen and the oxygen content in a laboratory analysis just to get some information if there's something going wrong or has gone wrong during the sample taking process, for example. So you have a certain ratio of oxygen and nitrogen when the sample taking process was okay. So this is an indication just for a right interpretation of the DGA results. So on an online monitoring system, it's not, in my opinion, it's not necessary to measure nitrogen. When you have a transformer that is closed and with a nitrogen gas phase upon, detecting nitrogen could be used for a kind of leakage detection, for example. But this can also be done with a nitrogen, with an oxygen measurement, for example, that it's easier to do. So the answer is very clear: for DGA interpretation, you don't need a nitrogen measurement.
Thank you very much. One last question. Once again, what is the accuracy of the DGA online system in comparison to the lab analysis?
Yeah, also easy question, not that easy to answer. The discussion about accuracies. When you look at, we start looking at accuracies, measurement uncertainties from a laboratory analysis, for example. When you compare laboratory analyses between different laboratories, this was shown in the last round robins done with over 15 laboratories in the last years. You can get differences between and uncertainties up to 25%. So you have a range between 21 to 28% differences between the results of different laboratories. And these are also the differences you can get when you compare results from an online monitoring system with a laboratory analysis and with laboratory results. When you look at the repeatability, so you look at the results of one system. You have several results over 1 hour, for example. then the repeatability of online systems are quite good, yeah, because you have automated sample taking processes integrated in these systems. Or like the DGA 2 and 3, you have mounted this system directly into the transformer tank. There is no sample taking in that sense. And there you have some measurement uncertainties, 5 to 8%, when you look at that. So it depends a bit to answer this question where you look at. You want to compare the results of one system, then you have a quite good repeatability. When you compare different results between different laboratories or between online systems and laboratory analysis, you can get quite high uncertainties, up to 25%.
So thank you very much to the two of you. These were some really great answers, giving great insight into the technology. So thanks again for explaining all of this in detail.
Thank you.
Thank you very much.